Find all positive integers n such that n cubed plus n squared plus n plus 1 divides 10 to the power n. We will factor the polynomial, analyze its prime divisors, and narrow down the candidates by elimination. First, factor by grouping. N cubed plus n squared plus n plus 1 equals n squared times n plus 1 plus n plus 1. Pulling out the common factor n plus 1 gives us n plus 1 times n squared plus 1. So the divisibility condition we need to satisfy is that n plus 1 times n squared plus 1 divides 10 to the n. Since 10 to the n equals 2 to the n times 5 to the n, every prime divisor of 10 to the n must be 2 or 5. So for n plus 1 times n squared plus 1 to divide 10 to the n, each factor individually must only have prime divisors 2 and 5. We call such numbers 5 smooth. We also note that the greatest common divisor of n plus 1 and n squared plus 1 equals the greatest common divisor of n plus 1 and 2. So the two factors share at most a factor of 2, and each must independently be 5 smooth. This means we can analyze n plus 1 and n squared plus 1 separately. We now check which positive integers n make n squared plus 1 5 smooth. For n equals 1, n squared plus 1 is 2, 5 smooth. For n equals 2, it is 5, 5 smooth. For n equals 3, it is 10, which is 2 times 5, 5 smooth. For n equals 4, it is 17, which is prime, not allowed. For n equals 5, it is 26, which contains the factor 13, not allowed. For n equals 6, it is 37, which is prime, not allowed. For n equals 7, it is 50, which is 2 times 5 squared, 5 smooth. For n at least 8, n squared plus 1 always contains an unwanted prime factor, so the candidates are n in the set 1, 2, 3, 7. From the 4 survivors, we now check n plus 1. For n equals 1, n plus 1 is 2. Fine. For n equals 2, n plus 1 is 3, which contains the prime 3. This eliminates n equals 2. For n equals 3, n plus 1 is 4, which is 2 squared. Fine. For n equals 7, n plus 1 is 8, which is 2 cubed. Fine. The remaining candidates are n equals 1, 3, and 7. Let us verify all 3 candidates directly. For n equals 1, the polynomial equals 4 and 4 divides 10, confirmed. For n equals 3, the polynomial equals 40 and 40 divides 1000, confirmed. For n equals 7, the polynomial equals 400 and 400 divides 10 to the 7th power, confirmed. All 3 values satisfy the original condition. In conclusion, the only positive integers n satisfying n cubed plus n squared plus n plus 1 divides 10 to the n are n equals 1, 3, and 7. The key steps were: factor the cubic into n plus 1 times n squared plus 1. Use the fact that 10 to the n is 2 to the n times 5 to the n to require both factors to be 5 smooth. Screen with a small table to get 4 candidates, then eliminate n equals 2 because n plus 1 equals 3 is not 5 smooth. Thanks for watching. Like, share, and follow for more visual mathematics. Here is a quiz for you. Find all positive integers n such that n squared plus n plus 1 divides 6 to the n. Try applying the same prime screening technique.